I'm John Gertz, SETI theorist, and we're continuing today with our discussion of the Drake equation. Um, and the factor coming up next for discussion is N sub E. This one really gets my goat. Um, this is Frank Drake's way of saying that the Earth is the best of all possible worlds. And therefore, in the equation is this factor of the number and the number of Earth like planets in each star system. Um, by Earth like, he means a planet which is not too near its star and not too far from its star, so that liquid water can exist on its surface. This is what's called the habitable zone. And for the Earth, or for our solar system, the ideal spot to be in the habitable zone is simplistically calculated to lie between zero point 0.7 and 1.3 times the Earth, uh, the Earth-Sun distance, or AU, astronomical units. But simplistically is the key qualifier here, since this is before any consideration of the planet's size, its atmospheric pressure, its composition, and the composition of the atmosphere, the amount of surface water, the presence or absence of volcanism, tectonic crustal movement, among many other factors that can make all the difference. By way of very, very, very concrete example, both the Earth and the Moon lay at the same 1 AU, or right in the middle of the habitable zone for our solar system. And whereas the Moon is as dead as a doorknob, the Earth, which is at the same distance, is bursting with life. Uh, Obviously, something made all the difference, and not the least of which is an atmosphere. So, leaving aside for a second the lifelessness of the Moon, the Earth itself provides an excellent example of how a simple calculation of the habitable zone can come up quite short. Um, Life formed on the Earth no longer ago than 3.8 billion years. It may have started even earlier than that, and personally, I'm of the belief, and we'll get to that, that it started maybe around 4.3 billion years ago, or 4.2 billion years ago. In any event, a G-class star like our sun warms up over time. It, if we run back the clock, we'll see that at the time that life began, the sun was only about 70 or 75% as luminous as it is today. That would have placed the Earth squarely outside of the sun's habitable zone at that time. Its oceans, if it had oceans, would have been frozen solid, and yet they were not. So how do we solve the riddle of the paradox? The saving grace here is that Earth's atmosphere is known to have been much different at that time. We don't know exactly what the composition of the atmosphere was, but it was rich in, presumably rich in lots of greenhouse gases such as carbon dioxide, methane, and water vapor, and others. Mars, which lay even further outside of the sun's habitable zone, or the solar system's habitable zone at that time, at the beginning of this solar system, also was suspected of having life. And again, it should have been frozen, but it wasn't, and that's because we know that its atmosphere was thick with carbon dioxide, and that is a very profound, as we know, greenhouse gas. So it was nice and warm and toasty and habitable on Mars's surface, where water flowed. Drake's N sub E also completely fails to take into account that there are Earth-like moons orbiting gaseous planets around, which orbit most or many stars. Gaseous planets are large, and because they're large, rocky moons that orbit them get stressed by the tidal tensions. The amount of gravity on the near side is stronger than the gravity on the far side, causing tidal stresses, friction inside the planet, warming up, heating, and consequently, quite a number of moons in our solar system have oceans underneath a layer of ice. There are water oceans around Europa and Enceladus and several of the other Jovian moons. In ignoring the tidal stresses, it essentially ignores any source of energy outside of solar energy. But there are other sources of energy besides tidal energy. There's the radioactive decay of elements within the core of a planet. That's why Pluto, which is not orbiting a large gaseous planet, nevertheless seems to have a subsurface ocean, possibly warmed by radioactive decay. M sub E completely ignores atmospheres as a place for possible life. Life doesn't normally replicate and metabolize in Earth's atmosphere because of a paucity of carbon compounds such as methane or CO2, by on which complex organic chemistry might be built. However, it's entirely plausible that life can and does exist in the thick carbon dioxide atmosphere of Venus or within the gaseous planets of Jupiter, Saturn, Uranus, and Neptune. Drake's N sub E would certainly ignore Mercury because it lacks a liquid water on its hellish surface and only has a trace atmosphere and experiences wide temperature variations between the cold side and the dark side. But nonetheless, it's now been discovered that there is abundant water ice at its poles, and there are volatile organic compounds in its subsurface to a depth of at least several kilometers. And there's subterranean salt glaciers indicating that subterranean life is hypothetically possible. Drake's N sub E would essentially also ignore this Saturn's moon Titan, which actually does have liquid on its surface, liquid rain, liquid rivers, liquid lakes. They're just not liquid water. They're liquid hydrocarbons. Life might exist in that liquid, albeit it wouldn't be life as we know it. It wouldn't be based upon DNA, which does fine in water, but not so well in liquid hydrocarbons. If it's reasonable to surmise that our solar system's truly possible habitable system extends from the subsurface of Mercury and the clouds of Venus all the way out to the oceans of Pluto and maybe further, that is anywhere where organic chemistry is possible, then surely the entire concept of the habitable zone is ripe for retirement, and N sub E can come right out of the Drake equation. What it might be exchanged with is maybe let's call an N sub TB, and the TB would be total bodies. So the total number of bodies that on which life might possibly exist. And that would include not just planets and moons, but also asteroids, comets, Kuiper belt bodies, and that have any place that has either a substantial atmosphere and or liquid water or liquid hydrocarbons, not necessarily on the surface, but maybe in the subsurface, wherever those liquids might be found. The resulting figure is certainly be much larger than the more restrictive and anthropocentric N sub E. One might argue that you can ignore asteroids or comets or Kuiper body objects because they don't fit into the larger vision of establishing the number of communicating civilizations in a galaxy. Because let's face it, I mean, life could arise on a comet, but it's not going to build high-rise apartments and video games or whatever. It's going to be obviously microbial at most. But that ignores the possibility of panspermia, which we have or will discuss in another video, and that life can travel from one place to another. So if a life arose on a comet and that comet later crashed into the Earth, voila, we are comet people in the final analysis. All right, so much for N sub E. I'm very happy to see it pulled out of the Drake equation, thrown into the ash heap of scientific history. And with that, I wish you all well and hope that you go to my website, johngertz.com, to link to my peer reviewed papers. These videos are merely thumbnails. You get the fuller arguments there and in my forthcoming book, Reinventing.